Hello everyone, this is Katish here. In this video, I'm going to go through the AQA Physics Paper 2 Higher Tier from 2025. Question number 4 is on the topic of waves. Telescopes are used to look at distant objects. Some telescopes use lenses to form an image. So if this question is about lenses, it will only appear in the triple science paper because this is only physics only content. It doesn't appear in the combined science papers. Figure 5 shows two parallel rays of light light incident on a lens in a telescope. The principal focus of the lens is labeled F. What type of lens is shown in figure 5? So if the principal focus is in the front, the lens should be convex lens. Convex lens, which basically will have this shape, right? Remember, this is a concave lens, which basically it spreads out the light. Complete the ray diagram for 2 marks. So you need to start that line from here, from the top, and it should go through F. I can get it straight, be a straight line. Start from there. Come on. There you go. And you follow that up with a arrow to show the light rays. So the marking scheme says the parallel rays converging, rays meeting, crossing at the principal focus. The James Webb Telescope can detect electromagnetic waves beyond the visible spectrum. The shortest wavelength of electromagnetic radiation that can be detected by the James Webb Telescope is 0.6 μm. That's micrometers. That is 10 to the power minus 6. So if I convert that to meters, I'll probably at some point have to convert it. 0.6 times 10 to the power minus 6 meters. That would give me a mark. The speed of electromagnetic wave is 3 times 10 to the power 8, which is the speed of light. Calculate the frequency of the electromagnetic wave, electromagnetic radiation that has a wavelength of 0.6 μm. Use the physics equation sheet. So speed of the wave is equal to the frequency multiplied by the wavelength. So speed is 3 times 10 to the power 8 equals the frequency multiplied by 0.6 times 10 to the power minus 6. So frequency equals 3 times 10 to the power 8 divided by 0.6 times 10 to the power minus 6. That gives me 5 times 10 to the power 14 hertz. 5 times 10 to the power 14 hertz. Complete the sentence. Electromagnetic radiation detected from distant galaxies is redshifted. This means that the electromagnetic radiation shows an increase in wavelength. Remember that red light has a bigger wavelength than blue light. Why is the electromagnetic radiation from distant galaxies redshifted? All observed light from distant galaxies appears red. That is not correct. Distant galaxies are moving away from our galaxy. That is true. The James Webb Telescope has detected electromagnetic radiation from many different galaxies. Electromagnetic radiation from one of the galaxies detected shows the greatest redshift ever observed. What conclusion can be made from about the distance of the galaxy? Well, the distance to this galaxy is greater than any other previously observed galaxies, right? Which means that it's furthest away than anything else that is observed. The James Webb Telescope is an artificial satellite that orbits the sun at a constant speed. Explain why the velocity of the satellite changes as it orbits the sun. Now, it's going at a constant speed, but it's going in a circle. Because it's going in a circle, its direction is changing. So, because the direction changing, velocity is also changing. Now, also, because it's going around the sun, since it's going in a circle, there's a centripetal force that acts on the satellite. So the satellite is actually accelerating towards the center of the orbit. So the direction changes, which changes the velocity. That's the answer that they're looking for. A centripetal force acts on the satellite. So the satellite accelerates towards the center of the orbit. So the direction changes, which changes the velocity. Since velocity changes, it's accelerating. That brings us to the end of question number 4, and I will see you in question number 5.